right, so we should be live now. We just when we start up the stream, we wait about 5 minutes or so just to make sure that everybody's in and set up before actually starting the show proper, and then we just slice off this part at the beginning. But let me see if I can get everyone to Brady Bunch mode. Because it's Paul Matt Sutter all the time right now.
Not necessarily a problem.
All right, this is super weird. All right. I'm kind of cut off. Yeah, there's gonna be some fixing to go on here. People are gonna need to tell me what's happening with our audio levels between the two halves of this, because I am not at my studio, as you can probably guess. People wondering where I am. Can you guess? Can anyone guess where I am?
Deep 13.
If anyone in the chat can guess where I am, then well, let's say hi to people. I'm here. Hello to Adam Synergy, Arnold Post, Benjamin Valamont, Barrett Klankar, Tureg Kahar, Colin Jones, Colin Smith. Oh, current resolution. The current resolution is 1280 by 720. Is this working for people?
I pulled up the stream and it looks good.
Okay, no problem. No problem. Hold on. I can be louder. All right, let's try that. Paul, people say that you're louder than me, which is really hard for me to compensate with audio, but we'll see what I can do.
I can just speak softly.
Yeah. How's
hey
that?
Guys.
How's that? Now I've increased my volume a little more. So we'll see if that, or maybe that just increased everyone's volume. I don't know. Turn that down. Paul is crazy loud.
Crazy loud.
Yeah, you're coming through really loud for me, but Paul is very loud. I am normal. So let me see if I can turn him down. Does that work?
Turn down for what?
Turn down Paul. Yeah, apologies in advance. We are at another studio, and so we're gonna do the best we can with this. I am in San Antonio. Actually, I'm in Austin right now, visiting my wife's daughter's graduation, and so we're here. So I'm using some. No one has guessed where I am yet. No one's guessed whose studio I'm at right now. So I'm still barely audible, and Paul is bursting eardrums. Okay.
Is there anything I can do on my end?
Do you have any control over your microphone?
I don't think so, but I'll check.
Yeah, let me try bringing you down a little more. I'm bringing down in the... Okay, you are ruining speakers is the word on the street.
Whoa. How about now?
Okay, I'm just going to bring you down. Okay, try again. What did you do?
I brought my input audio down, but now it's creeping back up for some reason. How can I?
Well, Windows tends to try and do that. If you're using Windows or Mac, they'll try and control the audio level.
Yeah, they're trying to do that, and I don't want that to happen.
Yeah. There you go. Nancy and Susie got it, but I think they know. No, Paul is fine. I must get louder. But if we're the same, I don't understand. Yeah, this is cool, isn't it? Yeah, so I'm at Brian Brushwood's studio. There, Paul is. I brought Paul's levels down a little bit. So, and then I think I'm gonna go do a scam school later on. Okay. So you sound better, Paul. I brought your volume levels down. I think that'll be okay. Apologize. I don't know how to make my side. Well, I can make my side a little louder from here. Let's see. Testing. There, that should be a lot louder on me. But then it's also like louder. I'm getting like echo. Anyway. Is this thing on? I'm still barely audible. It looks like I'm getting pretty good audio coming out of this, but I can go louder. Okay. All right, let me try this again. I'm going to say hi to a bunch of people. How far did I get? Hello to Alex Despland, Arnold Post, Ben Ufa, Benjamin Valamont, Bill K, Burke Clankar, Capital H, Jared Kahar, Citizen Gold, Colin Jones, Colin Smith, Connor Lennon, Darth Chocolate, Derek, Abron, Endo, Fleming Thurnberg, Fragger Fragsalot, Galaxia, Gina Rodkey, Granville White, Ignati Romanov Jangovsky, James Doyle, James Haney, Yan Dryak, Yan Yor Lawrence, John Baker, John Seffield, Larry Beckham, Liam Cockcroft, Lillian Brennan, Malcolm Bond, Matt Minter, Mr. The Grievous, Nancy Graziano, Neil Hutchinson, Neil Guguri, Peter Quinn, Phil Berthus, Rolo, Phil from Westby, SSI, I lost you there, Stephen Hawkins, Susan Hunter, Tak Tang, Teely Umu, Wayne Johnson, William Skiblo, and Zach Cody. Hey, everybody. Paul is still loud. Okay. You're still so loud, Paul. But I'm going to...
I could just whisper. We could talk about Hexagon on Saturn.
I'm just bringing down your decibels until we bring you into the realm. All right. I'm not quiet. I promise you, I'm not quiet. But I sound wonderful here in the studio. All right. I think we've had enough time for shenanigans. Yeah, I know he's going to look pretty silly, but we're going to switch this in a second here. Hold on.
Multiple people are complaining that they only see the top half of my face. It's a problem for them.
All right, we got the speaker. There you go. Okay. And that's you there. And there's me. Because I should remember that this is my microphone. Do not look at this. Look over here. And then this is a split a little lower than me. All right. I'm just going to start. Here we go. The Slack chat is covering a Paul's chin. No, he should probably move his camera down a little bit.
How's this, guys?
Let's see. That's a little too far.
Oh, too far.
Too far. Keep going. A little more.
How's there?
That's pretty good. Yeah, let's go with that.
I'm getting moving around a lot. Anyway.
All right, let's go. Here we go.
I do not need a facelift.
Okay. Don't whisper. Okay. That's my camera right there. It is the 12th of May. Here we go. Hello, everyone, and welcome to the Weekly Space Hangout for Friday, May 12th, 2017. I'm Fraser Cain, publisher of Universe Today. As you can see, I'm not in my normal studio. I'm in the Brian Brushwood studio where they do Night Attack and Cord Killers, and I happen to be in the Austin area and needed internet, and I had to make sure that we did a show. So here I am using the Brian Brushwood studio. Apologize in advance. I don't know how any of this stuff works. I'm amazed I was even able to make this happen at all. So joining me this week, we've got Dr. Paul Matt Sutter.
That's right, you do. How's it going?
Good. And there we are. Good. Welcome back to Weekly Space Hangout. Again, a big congratulations to Morgan Renberg, who is now Dr. Morgan Renberg. I think he's recovering nicely, and hopefully we'll see him in the next couple of weeks, and we can all say hi to him. And
Kimberly Cartier.
She got her doctorate as well?
I believe so.
Did it happen? Someone tell us in the chat if that happened. That's awesome.
Pretty sure she emailed me the other day saying her defense was the next day. And so that was a few days ago. So by, the principle of induction, I think.
Yeah. Your logic is strong in this one. All right. And so we're going to be talking about a bunch of stuff. We're going to be talking about Cassini finale its investigations into the Hexagon and this new amazing image of the Crab Nebula. So we'll be digging that up. Joining me as well this week as our special guests, where are they? So we've got Michael Summers and James Trefil, who have written a book. Let's see. Can you hear me, guys?
We can.
Oh, you're quiet too, aren't you? Can you mute your mic, Paul?
Already muted.
No, I hear you, though. All right. So, James and Michael, can we hear you?
Testing 1, 2, 3. Is that better?
Test.
All right, I got to switch the camera over to you. Weird. All right, apologies in advance. They're not going to speaker mode. All right.
Is there
No,
anything-
really wants to show Paul. All right. Again, apologies in advance.
Can't blame it.
Wrestling with other technology. All right, Michael and James, welcome to the Weekly Space Hangout.
Thank you.
Glad to be here.
So, can you let people know who you are and what you do?
I'm a professor of physics at George Mason University, and we've written this book about exoplanets, which I think is what you're going to talk about.
Yeah, your microphone, your levels are very quiet.
I mean, lean closer.
Yeah, well, it's the closer. It's just the volume. So I might have to go the opposite way when you guys talk than when we've got Paul Metzetter. Yeah. Let's see. I was wondering what was going on. Yeah. So once again, you are exoplanet researchers from where?
George Mason University, which is in the state of Virginia, just outside of Washington, D.C.
Yeah. Very quiet. Apologies in advance. I can't figure out why the audio level is so low. I can try and boost it. So, but Paul, you can't talk. Don't even talk to say, okay, I won't talk. Because it's going to be so loud. Okay. So I'm going to try boosting your levels. It's going to get a little weird here. Let's see if that works. Can we try again? Can we hear you again?
Okay, test, or you wanted to start the...
Yeah, so let's go even louder. All right, try now.
We'll try again. This is testing to see if we've done it. Which we
Yeah,
haven't.
so I don't know if people can hear them okay at this point. Now, let's see if I can go from there. Try again.
Okay, I'll try again. How's this working?
All right, I think that's a little louder. All right. Sorry about that, everybody. Let's. I'm not gonna keep boosting their volume. Yeah. Okay. All right. Let's go. All right.
Well,
Great. So exoplanets.
We're scientists, so we understand about fiddling with knobs.
So which now you've just released your book. Have you got a copy kicking around of it?
Here we do.
Yep. Here it is. Can you see?
That's fantastic. All right. So, and what is the sort of latest then on the exoplanets? What brought you into doing the research that you've been doing?
Well, from our point of view, this is one of the most exciting fields in science right now. And we're discovering not only a lot of exoplanets, which is a new piece of information, but this incredible diversity among the exoplanets. If you can imagine a world, the chances are it's out there.
And I mean, I remember like even when I started doing, being a science journalist back in 1999, I think we had just discovered the one planet, PEG 51, and the Pulsar Planets, of course. And now here we are. We have close to 10,000, like what, 8,000 confirmed planets thanks to Kepler. And
About 3,600 confirmed and about 4,000 more candidates.
right.
And we're discovering new worlds at the rate of about 2 per day, if you average it out. So 2 whole new worlds every day. Think about that.
And that's just the beginning, right? I mean, there's of course the Gaia mission that's going to be turning up many more, as well as tests, all these new missions coming up. So we're really at the early stages of being able to find planets, and yet we've already found so many.
Yeah, we've looked at this tiny little piece of the galaxy so far, and they're all over the place.
Yeah, absolutely. So, with your book, you cover, but a lot of the sort of more the stranger, as you said, the pulsar planets. How are the exoplanets that we're finding matching up to what our expectations were for what was going to be out there?
I'll take that one. I think they're far beyond anything we expected or anticipated or even imagined. We're just finding just about everything you can imagine out there, from habitable planets that are somewhat like Earth to things that are completely different. Planets made of metal, planets made of carbon, planets made of water, planets that don't even orbit stars, but that float around between the stars. Planets that orbit 2 stars, planets that orbit 3 stars, planets that orbit 4 stars. You probably heard the TRAPPIST-1 system, 7 Earth-sized planets sort of lined up together around a small M-dwarf star, and 3 of those in the habitable zone. So to me, just about every single one of them is pretty exotic and pretty unusual. It's almost like a humbling lesson in what the laws of physics can do, far beyond anything you can expect.
And I think that's one of the big things that was a big surprise. I think when exoplanet researchers first started out, they were expecting them to be that our solar system was the normal, average kind of planetary system that you would find out there. And now what we're finding is that, in fact, they have all of these different configurations. I mean, the first planets that we found were these hot Jupiters, and that was just so unexpected.
Yeah, the thing is that the 30 or 40 years ago, there was an honest debate about would there be any other planetary systems out there? And then once we began finding them, we said, well, we understand how our solar system formed, and it seems so logical and rational and all laws of physics and everything. And suddenly we're finding these things that we never imagined could be there.
I mean, there is one way that our solar system is somewhat typical. Surprisingly, if you extrapolate the numbers that we're discovering, there will be about 10 planets around every star in the sky. So that's pretty astonishing in itself. I mean, that is sort of typical.
And so right now, I mean, the techniques that we use to find these planets, we've got, of course, the Kepler and now unfortunately Kepler's having its problems, but it's found many of the planets that we're doing. What do we think that we can expect in the next couple of years as these new observatories, new techniques come online? What's sort of next in the field of exoplanets?
Mike's just taught a course on this very subject, so I'll let him answer it.
Well, next year, you mentioned TEST, which is going up. That's going to look at the nearby bright stars, that are probably within 100 light years or so. And the neat thing about that mission is it's going to cover most of the sky. So it will find most of the planets down to Earth-sized planets that are within 100 light years. And then our larger telescopes, like James Webb, which is also planned to go up next year, they can then do dedicated intensive study on the planets that have been found. So I would say in the next year or two, we're going to be finding several times as many planets as we already know. Plus, we're going to be using the larger telescopes to get atmospheric compositions, to get winds, to get temperatures, and to sort of characterize some of these stranger objects.
I think the holy grail, of course, for everybody is for us to attempt to try and find life out there among some other planet, some way to directly observe the atmospheres of these other worlds and try to get a sense of like what kinds of, what chemicals are there, what could be producing them. Where do you think we're at the search for being able to actually directly observe the atmospheres of these other worlds?
Well, yeah, there's a great deal of interest in what we call biomarkers or biosignatures. things that are chemicals, trace gases that would indicate biology. Just like you're breathing oxygen right now that comes from photosynthesis. And there's methane in the atmosphere as well that comes from certain types of bacteria. Those gases would not normally be in an atmosphere on a planet like this. We would, without biology, expect to have a carbon dioxide atmosphere like Venus or Mars. So looking for gases that are a little bit unusual, that should not be there in a stable equilibrium system is something we're paying a lot of attention to. The problem is it's incredibly difficult to find any particular gas or any set of gases that actually prove the existence of life, because there's so many ways of getting the different chemical compounds that we find in atmospheres. It's a hard problem. If we find intelligent life beaming signals to us, that would be much easier. But finding simple life could be very difficult.
The fact that we're still having these tremendous debates about Mars, where we've been, we've got orbiters, we've got landers, it tells you just how hard it is to nail this down.
Yeah.
Imagine trying to do that for a planet that's light years away.
Yeah, we've known that there's methane in the atmosphere of Mars for over a decade, but we still don't know if that comes from life or not. There's a large debate about that. It may be possible in the case of Mars to eventually figure out if it does come from biology, but that's a nearby planet. You know, what are you going to do with something that's 40 light years away? So it's going to be difficult. I'm not sure what the answer is. It's hard.
I think one of the big revolutions that's happened in the last little while is how you can start to find these planets from ground-based observatories. There's a lot of these new observatories and new instruments being attached to some existing observatories that are aiding in the search for ground-based observation. Do you think that the search is going to be more fruitful from space or from the Earth?
Personally, I think everything is going to contribute somewhat to the search because there are so many planets. It's going to take every telescope we have time on to characterize them all. We've got to do a survey and then detailed searches. That's going to take, you know, if you had all the telescopes on Earth just doing exoplanet research, you could still not survey all the planets that we're going to be discovering. You could still not be able to characterize their atmospheres. So I think every telescope, even smaller ones, even modest telescopes down to the size of a meter, can do some really significant research in exoplanet studies and characterization. So what's going to be the best? That's hard to know. Space-based telescopes are certainly better because they're above the distortion of the atmosphere, and they can explore wavelengths in the infrared that are hard to do from the ground. But then you could have much bigger telescopes on the surface of the Earth, and as you mentioned, you know, having instrumentation that can correct for the distortion of the atmosphere can make them in some ways just as effective as they would be in space. So I'm not sure there is a best. I think all of them are going to be contributing something.
So I'd like to talk about some of the more interesting exoplanets that are out there. What are some of the like really weird, unusual, extreme planets? Can you give us some examples of stuff that's out there that maybe would defy our comprehension from our human orientation?
Yeah, the one that I always use when I want to astonish people is Cancri 55e. This is a planet that's actually, if you want to get technical, inside the star, inside the outer atmosphere of the star. And it's a carbon planet. Probably you have volcanoes on it bringing liquid carbon up and spewing out diamonds, which would be a spectacular sight. And so if I have an elevator talk and someone asks me, that's the one I always use.
That's amazing. So it's orbiting inside the star. So is it doomed?
Maybe. I don't think we know that yet.
I mean, it has an orbit of about 18 Earth hours. So that tells you it's in the corona, and there's probably a very strong interaction with the atmosphere, some sort of drag, maybe magnetic, electromagnetic drag as well. I would suspect it's doomed eventually. But it's a complicated place. We don't know its magnetic field. We don't know its atmosphere. So it's hard to know how long it's stable like that. But with such a close orbit, I would not want to buy property there.
I think that's a really good place.
Give me another one. That was pretty weird, but you can do better.
Well, oddly enough, I think that the water worlds are pretty interesting. You might think that a planet that's made of just water would be kind of boring, water from the surface all the way into the core. But there's several things that make them interesting. One is that they're probably not pure water. They probably have a core that is rock and metals, where you would have activity a lot like the Earth. You'd have plate tectonics, and you would have volcanoes, and you would have an ocean several thousand kilometers thick of water. And as you go in from the outside towards the interior, you would experience water changing phase many times. Water at high pressure has over a dozen phases. And every time the water changes phase, there would be a density gradient. So the first time you encounter that density gradient, it would be like a surface that would hold up certain types of light molecules and substances. Then you go down further, there'd be another density gradient, and you would have a different type of substances. So in a way, it's like an onion world. Each layer would be its own pressure, temperature regime. Each layer would have its own oceanic meteorology. Each layer would have its own compositional gradients. So you could potentially have a dozen different types of complex organics or chemistry going on inside of a world like that. And Jim and I have talked about how a civilization might develop inside a water world. If you had something like an octopus that got really, really clever and used whatever tools were available, you could have life in one level that could fight, have wars with life from another level.
Now we're talking. That's awesome.
Yeah, I mean, and this is just water. I mean, think about a simple little water world.
Yeah.
And then you think about the worlds that are completely away from stars. I mean, the tendency is to think of those as being dead, but they're not, because you take even a planet like the Earth takes 10 billion years to cool off. And if you took a water world and injected it into space very quickly, you would have an ice crust, but everything inside of it would continue. If you took a system like Jupiter and its 4 moons, Io, Europa, Ganymede, and Callisto, and just shot those into interstellar space and asked the question, what would happen? The answer is not much. I mean, Jupiter gets most of its energy from its interior. Io, Europa, Ganymede, and Callisto all get their energy from gravitational tidal interactions. Io would be just as active volcanically. Europa, Ganymede, and Callisto would each keep their subsurface liquid water oceans, and that would go on for tens of billions of years. And so, the interstellar medium, I think, is going to hold some surprises for us. There could be a lot of havens out there that are very habitable, even for terrestrial type life.
Yeah, the analogy we like to use is we say these so-called rogue planets are like houses where you've turned off the lights but left the furnace on. And so you have all the sources of heat except the heat from the star are still there. And you could even have surface oceans on planets like that.
And then think about what it means if they're common. I mean, some of the numbers suggest that there may be 10 times as many rogue planets as there are gravitationally bound planets. That would completely change our notions about interstellar travel. What you would do is that instead of going 5 to 10 years at a hop in a generation starship, you would travel a few thousand AUs, stop, refuel, get some resources, maybe set up a colony, terraform a world, then find the next rogue planet, head on to that one, stop, do the same thing. You could colonize the galaxy in much smaller steps, but and it would be slower, but you would do it a lot easier and with a lot less sophisticated technology.
You wouldn't need warp drive.
Well, I think you'd prefer them. I mean, I think we still, this is, of course, the problem. I think the great sadness everybody has is when we discover these worlds, we find out about TRAPPIST-7 and things like that, and how interesting these worlds are, and then we realize how difficult it would take for us to actually get to a place where we could see them. I mean, that's the that's the shame, is that really our imaginations are going to have to take us most of the way with all of these planets.
I think you're right about that.
Or the distant ones. But again, think about what happens if you have a rogue planet a few thousand AU from our solar system. Within a couple of centuries, we could have the technology to go there and set up shop and possibly colonize or get, like I said, refuel. So that could be a big surprise.
Yeah. Sorry. So let's, as I mentioned, let's show the book again, and we're gonna do a giveaway of the book. So there is the book. Maybe hold it back a little bit here. Pull it back a little bit. I don't think we can read. So I think go back. All right. So Diamond Worlds. There you go. Exoplanets. Summers. James Trefil. Now we've got a list. I think Nancy, you had a list of all of the names of the people. And then I'm going to roll a random number, and we're going to pick 2 names off that list, and you're going to win. So, all right, let me see. Okay, I'll go back up to the list. So people in the chat should be able to see the... Oh, looks like I've lost the list. Oh, there's more. Okay, hold on.
Can I enter the competition? I'm out of my copies.
Are you all out of copies? Okay, here we go. So we've got 39 names on the list. I'm just running through them really quickly here. All right, and I'm gonna pick a random number from 1 to 39. All right. So I got number 28. So this is the first one. So number 28 is Vicky Noor. So there you go, Nancy. You saw that one, Vicky Noor. I'm gonna do another one. Here we go. Number 14, Raza Siddiqui. And there's number 14, Raza Siddiqui. Awesome. Fantastic. All right. Cool. So if people want to find out more, obviously they can buy the book. Where can they find out more of the work that you're doing and follow along?
Well, I'm working at George Mason University, but I'm on several science teams. The New Horizons mission to Pluto, I'm a lead scientist on that. So they can go to the New Horizons website to see the work we're doing there. We have a website in the Physics and Astronomy department here at George Mason University. Or if anyone has questions, they can just send them directly to me, msummers@gmu.edu. I'm up late at night, almost every night, emailing students and people all over the place who are fascinated and have questions about this stuff. You're right. It is a field ripe for imagination, but yeah, I think our technology is going to overtake our imagination pretty quickly now.
Well, that's always the part that I always would feel so worried about writing a book about this, is that I'm sure it's out of date already, and you're going to have to release a new version, and yet you could never write the book then if you just kept having to wait for it to be not out of date.
Yeah, this book came out 2 weeks after the TRAPPIST-1 system was discovered. And then GJ 1132b was discovered. And then the ice world was discovered with microlensing 13,000 light years away. And then just this week, they discovered the Neptune planet that has almost no metals, just hydrogen and helium. Yeah, every week there's some major discovery. Think what it's going to be like a year from now with TESS and James Webb, and then the other telescopes, the really big telescopes, the 10-meter size telescopes on Earth that are going to be using adaptive optics to try to get images of these planets. Within a decade, we'll be able to see if there are continents on Proxima Centauri b, the Earth-like planet nearest to our solar system, about 4 light years away. We'll be able to see if there's continents, if there are clouds, possibly storms. And that's on top of having compositional information and looking for biomarkers.
Yeah, it's a pretty amazing time. Well, James and Michael, thank you so much for joining us on the Weekly Space Hangout today. Congratulations on getting the book out the door, and I guess I look forward to the next edition when all of the new updates get incorporated.
We're working on it.
All right, thanks a lot for joining us, guys.
Thank you. Goodbye.
All right, so now we need to get Paul Sutter to, man, he's going to come in loud, I'm sure. I'm going to turn down the audio just to be safe. Paul, are you there?
I'm here. How'd that sound?
You don't sound so bad, actually.
Okay. All right.
Yeah, I think we're kind of
Take
even.
it. Take it.
Yeah. Sorry you didn't win. Free book, Paul.
I suppose I could just buy the book.
Or have the university buy one.
That's a much better idea. I'm typing the email right now.
Yeah, get them to send you the book. All right, let me. No,
See, I just don't think creatively enough.
Man, don't you? I'm crawling in books. I've got so many books that I have to read that get sent to me. I know it's like a real problem. All right, well, let's get on with
I might be busy writing a book.
You might be writing a book?
Mm.
Are you allowed to talk about that? No. All right. All right. Well, where should we start?
People are saying I'm super loud.
Super loud.
Well, just one person with really sensitive ears, so I don't know if I would trust them.
I've got you turned down pretty well, so yeah, of course you're gonna have to. Yeah, there was something that was going on. Lots of echo, and you're super loud. I can turn you down a little bit more. The problem was that their audio was really low, and so I'm not sure what was going on there. I don't know. We're here. We're making it happen.
This is uncharted territory.
We're in such uncharted territory at this point. All right. Well,
come on. I gave you the segue. Use it. Uncharted territory. Speaking of uncharted territory,
we're going to talk about the Hexagon on Saturn.
Yeah, sure.
All right.
NASA's Cassini mission, which is in its grand finale, its final 22 orbits of the planet that are going to send it passing through the ring system itself and also skimming the atmosphere. It's already done a couple of these and will continue until September of this year, I think. In which case, they're going to send it just crashing straight into the atmosphere in a death plunge. But already these close passes are giving us some new information about the structure of Saturn's atmosphere, and especially this enigmatic structure at Saturn's North Pole, this hexagon. It's actually a real geometric figure, and it's one of the most beautiful things in our solar system. Wouldn't you agree, Fraser?
Well, this was one of the things that Cassini saw, as or that the Voyagers had hinted at, and they weren't really sure that these things were real. And then Cassini has studied this now much more greatly. Now, what forms this hexagonal shape? Do they know what causes this standing hexagon storm?
Yeah, we're of course we're not exactly sure, like 98% of the things in space, but we do have a pretty good idea. We think at the very north pole of Saturn, there's a vortex, a giant hurricane that's stirring up the atmosphere and making the winds at the North Pole go very, very, very fast. And then as you go down in latitude, as you go further and further south, the winds slow down. And so there's a boundary between the fast winds and the slow winds, making a circle around the North Pole, almost like an Arctic circle around the North Pole of Saturn. And where fast winds rub up against slow winds, they can turn in on themselves and they can start mixing up and form small vortices of their own. And you can get a few naturally forming vortices, anywhere from 1 to 20. And as soon as they form, as soon as they pop up, they naturally press up against each other, and so they'll evenly space themselves out. So in the case of the hexagon, there are 6 evenly spaced storms forming a circle around the North Pole of Saturn. And these low pressure systems, these storms, these hurricanes, they press the jet stream up a little bit north. So it's almost like they passed the jet stream, that the stream of high velocity winds, like if you have a bunch of friends standing in a circle to play frisbee, and they pass the frisbee to each other along the straight edges between each person. It's kind of sort of like that, but at a few hundred miles per hour, and using storms instead of people. So you have 6 evenly spaced storms that are passing the winds off to each other, and that's what creates the hexagonal pattern. We've demonstrated this in the laboratory, obviously not with Saturn-like conditions, but we can form different geometric figures. We can form hexagons, octagons, dodecagons, but they don't happen in all cases. It requires a very particular mix of wind speeds and densities. So that might explain why it's only Saturn's northern hemisphere that gets a hexagon, and not its southern hemisphere, or not any of the other giant planets.
People are wondering why your echo disappeared, and that's because I'm now muting myself. So clearly it's coming out of the speakers. I would put on headphones, but I don't even know where the headphones are. So I'm just going to keep muting myself as Paul talks. Weird. Anyway, so this is, are there a bunch of mysteries left to try and figure out with this hexagon? I mean, is it, Cassini's going to get closer and closer views of this structure?
Yeah, so that's exactly it. So what I painted was a very broad brush, kind of just initial guess of what we think might be explaining the appearance of this hexagon. But there's so many unanswered detailed questions. And in order to answer those questions, we have to get more observations of the wind speeds at different latitudes of Saturn. So as Cassini makes these dives, it passes over the North Pole and moves south, and it takes thousands of pictures as it's moving south, and taking measurements of wind speeds, so we can get this nice little cross section passing through the hexagon and then out of the hexagon to look at the behavior of these winds. And the mission scientists already remarked of how sharp the boundaries are between the inside and outside edges of the hexagon. They're being maintained very, very, very well, and we're not exactly sure how.
All right, so I know that Cassini, I'm not sure exactly where Cassini is going to be crashing when it does wrap up its side of the mission, but boy, it'd be pretty cool to have it like just ditch right in the middle of that storm and trying to get to the bottom of that. But
that would be amazing. I think it might be. I'm not sure either. Maybe someone in the chat knows, but I don't know.
No, I'm pretty sure it's not going to be. It's just going to be sort of hitting in the mid latitudes, but that would be
right in the gut.
I mean, I really wonder what's going to happen over the next couple of months as we get closer and closer to that final crash landing. What are going to be some of the new discoveries that are going to come out of Cassini that we're then going to be able to, that's just going to, I guess, need us, with it being so close to Saturn and seeing the rings from this really unique angle and seeing these atmospheric structures, it's going to be a whole nother world. And it's almost like you wish Cassini could have spent more time.
You wish this was the mission where it's doing dives where it's going to spend a few orbits skimming the atmosphere to collect some samples. It's going to smash through the rings using its radio dish as a shield to protect the scientific instruments in case it actually gets hit by a little bit of ice. And to study the rings, the first time we've actually flown something through the rings or flown something through the atmosphere of Saturn. It's gonna be great.
All right, so the next story that we're going to talk about briefly is an updated image of the Crab Nebula. And I apologize, I can't bring the image in, but you can just Google search it. It's everywhere right now. So let's talk about this new updated data on the Crab Nebula.
Yeah, so the Crab Nebula, the remnants of a supernova that exploded 950 years ago. And this is the expanding shell of debris from that explosion, now at a radius of close to 900, or do you know the diameter of the Crab Nebula? 10 light years in diameter? There it is. So this shockwave is moving at a tenth the speed of light, 100th the speed of light. And one of the most fascinating things about this new image, which we've been observing the Crab Nebula for a very long time, is this combination of high resolution images from infrared, from visible, and from radio, all composited onto the same image. And the different physics that are happening inside of this structure generate different kinds of electromagnetic radiation. So we have the pulsar in the center that's generating, hot X-rays. We have visible light from fluorescence. We have radio waves from a synchrotron emission as electrons and charged particles get spun up in these complex magnetic fields. And one of the most interesting things in the image is near the center, where there appears to be these concentric ellipses of gas. And coming out of these concentric ellipses looks like two polar jets, just like you would find around a blazar or around a binary star or around an active black hole. We see jet systems all over the place in astrophysics, but these jets don't appear to be attached to the pulsar itself. And one is emitting in radio waves and the other, I think, is emitting in X-rays. So they're being generated by different physical processes, and they're not being directly generated by the pulsar itself, by the leftover core of the dead star that's rapidly spinning. It's not being generated by that. It's being generated by something surrounding it in the nebula itself. And as far as I know, this is the first time we've observed something like this, where there's jets being formed, but not from the compact object at the center itself, which is pretty cool.
That's pretty strange, because that would absolutely be my go-to assumption, is that the thing that's causing any kind of disturbance in the nebula itself is some kind of, the pulsar that's in the middle of it. I mean, I'm always really fascinated by these supernova remnants. The Crab Nebula is one of the more classic ones that we know of, and it really looks like a star went kablooey. But then there's some other ones out there, like the Cygnus Loop, which are ones that are sort of further in the future, where the size of the loop, the size of the ring that's expanding is much larger. It takes up a much bigger chunk of the sky, and it's also fainter and older. And so you can kind of see what the future holds. When we see these things, the Crab Nebula and other supernova remnants, we're only seeing something that's going to be visible in the sky for a few thousand years, and then it's gone. This is, this star exploded fairly recently. So, I mean, you've posited a mystery here. What's causing these strange elliptical, these ellipses structures in the nebula? They're certain it's not coming from the compact object in the middle. Does anyone have a theory, or is it just like, that's weird?
I think we're at the state where the observations are so fresh and so surprising, where these jets aren't attached to the compact object. We have these elliptical ring-like structures that suggest that there's some sort of magnetic field dynamo operating, where somehow there's turbulence or there's rotation in the nebula itself that's activating jets, that's sending out material in a ring-like fashion and having multiple repeated emission events so that it builds up a ring of material, ejects it out. Maybe that folds back to drive a magnetic field to create the jets, but then the jets shut off and then another ring appears and then the jets turn back on. Maybe there's something back and forth like that in the complex physics between the jet and the nebula material itself. That'd be my first guess, but that's going to take a lot of work to confirm that kind of idea.
How long till we get to see a really nice visible supernova in the sky, like the one that generated the Crab Nebula, which was visible very brightly back in the day?
Oh yeah, any day now. I mean, if Beetlejuice goes, which it's due to blow up. It will be spectacular. It'll be visible during the day. Um, I mean, just be patient. It's bound to happen.
To within the nearest 500,000 years or so.
Well, I'm supernova are pretty common in a typical galaxy. You get around 5 to 10 supernova per century, at least, and it's just a matter of one being close enough and on our side of the galactic disk, so there's not too much dust and gas between us and that supernova that we can actually see it, and especially see it during the day. It's every few hundred years.
Okay, well, I think you had only 2 stories. So I think we've reached the end of this week's Weekly Space Hangout. Apologies, we're a little shorter, but I'm kind of done wrestling with technology. So I think we were set up to do Astronomy Cast after this, but I think I'm gonna push that back because I'm not gonna be able to be sure that I'm gonna get a good quality audio stream. So I don't think we're going to do an Astronomy Cast after this. So thanks everyone for showing up. Apologies for the sound levels. I know that is always the thing that drives everyone crazy. All right, Dr. Paul Metzetter, where can people find out more?
Hey, can I plug something really cool? Yes, he thumbs up because he's muted. I'm getting a radio show, like a straight up terrestrial radio show, and podcast and live stream. All that's coming, but it's called Space Radio. It's launching on WCBE FM in Columbus, but we're recording the pilot on Thursday, May 18th at 4 p.m. Eastern time, and the whole point of this show is so that you can call in and ask me questions and we can talk about space and have a great time. So if you want to be a part of history of the pilot episode, the very first episode of Space Radio, I need you to call a phone number. I need you to call 614-365-5711. Call that number anytime between now and Thursday the 18th. Leave a message with your name, your callback number, and the question. And then what we'll do during the pilot recording is we're going to call you back to get you on the air to talk to me on the radio for the pilot recording. So you need to call 614-365-5711. Do that anytime. In fact, do that now. Do that right now. And if it's busy, do it 5 minutes from now. Wait your turn. Get that question recorded so that we know to call you back. The show will be recorded 4 p.m. Eastern Time, Thursday, May 18th. SpaceRadioshow.com for more info.
And SpaceRadioshow.com, the number is going to be there as well?
Absolutely.
Awesome. All right. Well, let's wrap things up. Thanks everyone for joining us. Thanks to our special guests. Go buy their book. Congratulations to the winners. And a big thank you, as always, to Brian Brushwood for letting me use his studio here in Austin. I really appreciate it. I love I'm jealous. I mean,
and you just broke it.
I'm sure this studio could do precisely what I wanted to do, but he's not around. So, again, but a big thanks. And if you haven't already, go check out The Modern Rogue. Scam School, maybe that I'm going to be on an episode of Scam School shortly, so that's a thing, and as well as his show Cord Killers and Night Attack. So there's lots of good stuff coming from the Brian Brushwood, the House of Schwood. All right, well, thanks everyone for joining us today, and we will see you all next week from my regular studio. Bye, everybody. All right, I'll stop the stream somehow. Where do I stop the stream? Oh, right, over there.